Hey everyone, and welcome to day one of our 3D printing series. I'm really excited to kick this off with you as we begin our journey into the world of additive manufacturing. Whether you're completely new or just brushing up on your knowledge, this series is designed to take you from the basics to the big innovations shaping our future. Today, we'll cover what 3D printing is, how it works, its history, real-world applications, and what the future might look like. Let's get started.
So, what exactly is 3D printing? Also known as additive manufacturing, 3D printing is the process of creating three-dimensional objects from digital designs by adding material layer by layer. Unlike traditional manufacturing methods, where material is removed from a block or mold, 3D printing builds the object from the ground up. This approach offers greater design flexibility, less material waste, and the ability to create incredibly complex shapes. The process starts with a 3D model, typically created using CAD, computer-aided design software. In some cases, a physical object can be scanned using a 3D scanner and turned into a digital model. Next comes the slicing stage, where the model is digitally divided into thin horizontal layers. These layers become instructions for the printer to follow. Then comes the actual printing. The printer deposits material, such as plastic filament, liquid resin, or even metal powder, one layer at a time. Each layer fuses with the one below, and gradually, the object takes shape. Materials used in 3D printing range from everyday thermoplastics, like PLA and ABS, to advanced materials like titanium, ceramics, and even biocompatible substances used in healthcare. To really understand how far 3D printing has come, we have to go back to 1983. That's when Charles Hull invented stereolithography, commonly called SLA. It was the first technology that used UV light to solidify liquid resin into a 3D object, layer by layer. The first object ever 3D printed? A small plastic cup, a simple object that showcased the groundbreaking potential of building things layer by layer. Just a few years later, in 1986, Hull secured a patent for SLA, marking the formal birth of 3D printing as a legitimate manufacturing technology. His company, 3D Systems, quickly began to grow, paving the way for the technologies we rely on today, in industries like aerospace, healthcare, and automotive. The 1990s were a time of rapid innovation. New types of 3D printing technologies emerged, such as selective laser sintering, or SLS, and fused deposition modeling, FDM. SLS used lasers to fuse powdered materials like plastic and metal, while FDM worked by melting thermoplastic filament and extruding it layer by layer. 3D Systems and Stratasys, two pioneering companies, pushed these technologies into industrial applications. By 1992, Stratasys had launched the first FDM printer, making the technology more accessible and cost-effective. Industries like aerospace and automotive started adopting 3D printing for rapid prototyping. For instance, in 1999, Ford Motor Company began using SLA and FDM to prototype car parts, significantly reducing the time and cost of product development. As we moved into the 21st century, 3D printing started making its way out of industrial labs and into homes and small businesses. In 2009, MakerBot released the Cupcake CNC, one of the first affordable desktop 3D printers. It allowed hobbyists to print objects using PLA filament, and sparked the rise of DIY and open-source 3D printing. Material innovation played a big role during this period. Biodegradable filaments like PLA became popular due to their environmental benefits, and stronger plastics like ABS opened the door to more durable prints. The open-source RepRap project, launched by Adrian Boyer in 2005, aimed to create a self-replicating printer, one that could print parts to build another printer. This movement made 3D printing more affordable, more accessible, and more collaborative than ever before. Fast forward to today, and we see 3D printers that are faster, more precise, and more versatile than ever. The Formlabs Form 2, released in 2015, is a great example of this. It uses SLA technology to produce highly detailed models, perfect for fields like dentistry and jewelry, where precision is everything. One of the most exciting developments is bioprinting. In 2016, the company Organovo created the first 3D printed human liver tissue, which is now used for drug testing. Eventually, This could lead to the ability to print entire organs for transplantation. Sustainability is also becoming a key focus. Companies like Philibot now produce filament from recycled plastic bottles, helping reduce waste and promote circular manufacturing practices. So, where are we headed? The future of 3D printing looks even more promising with the integration of artificial intelligence and the Internet of Things. Carbon 3D, for example, uses machine learning in its digital light synthesis printers to automatically adjust settings in real time, improving quality and speed. In construction, 3D printing is changing the way we build. In 2018, a company called ICON successfully printed a small concrete house in less than 24 hours, making affordable housing a real possibility. A year earlier, AppSecor built a 3D printed house in Russia using a mobile printer and special concrete mixture. And then there's space. NASA has already tested 3D printing aboard the International Space Station. In 2014, they printed a replacement part in orbit, eliminating the need to send it from Earth. In the future, astronauts may use 3D printers to build tools, habitats, and even spare parts on Mars or the Moon, using local materials.
3D printing is making a major impact across industries. In healthcare, it enables custom prosthetics, patient-specific surgical models, and bioprinted human tissues by companies like Organovo. Aerospace firms like GE Aviation and NASA use it to create lighter, stronger parts and mission tools. In the automotive world, Ford, BMW, and Volkswagen use it for prototyping, lightweight components, and printing spare parts on demand. Education also benefits. 3D printing brings STEM to life by helping students visualize complex concepts, design real projects, and gain hands-on prototyping experience.
And that brings us to the end of our first session on 3D printing. We've covered what it is, how it works, where it came from, how it evolved, and where it's going. From printing prosthetics to building houses and even exploring outer space, 3D printing is truly changing the world. Thanks for watching, and I'll see you in day 2, where we'll explore the different types of 3D printing technologies, like FDM, SLA, and SLS, in more detail. See you then. Don't forget to like, share, and subscribe so you don't miss the next video in this series.